Welcome back, everybody. My name is Nick, and this is Swiftful Thinking. Swiftful Thinking is the fastest way to become an expert iOS engineer. We cover all things Swift and Swift UI related. If you're not subscribed, hit that subscribe button. But if you really want to join the community, join our Discord. It is growing. There are active conversations in there all the time. It's a ton of fun. Well, with that said, in this video, we're going to dive into what is object-oriented programming. We're going to do it in specific relation to Swift and iOS app development. Now, I want to caveat here that most of what we are talking about in this video, I do not expect a beginner, someone who's just learning to code, to fully understand. And I don't think at the end of this video, you should have a full, complete understanding. But what I want to do is actually just introduce you to a lot of these subjects. So at the very least, in the back of your head, you have a high level understanding of what's really happening in our code. And I think overall, this will help you guys on your journey of learning how to code. I do have more advanced videos on my channel that we can actually dive into some of this. But if you are just learning, I don't think it's worth the time to even go that deep into a lot of these subjects. So what we're going to do is a very high level of object-oriented programming. Some of the things that we're going to talk about are creating and destroying objects. So how we can initialize or de-initialize an object, and what it means to put one of those objects into memory. What is allocating or deallocating something from memory? We're then going to move that into what is the actual memory that we were talking about. Memory breaks down into two sections. We're going to look at the stack versus the heap. Again, this is something that I don't think you need to know at the deepest level, but at least let's get a high level understanding because it's going to help us in the next couple of videos. While we're looking at those different types of memory, we're going to dive into some of the types of objects that are in both of those types of memory. So we're going to look at something called structs. We're going to look at something called classes. And that's going to segue us into the next video. So the next video is going to be actually on structs. And then after that, we're going to do one on classes. Those are custom data types that we can create in our code. So the same way that we have strings and Booleans, we can make our own types. But the problem is that I don't want to just start making those types without first explaining to you guys what those types really mean in our code under the hood. So that's why this video is first before we get into that. It's just to get a high level of object-oriented programming, a very high level introduction of what is the stack versus the heap, what is multi-threading, but we're not going to actually do a deep dive into any of that. So this is going to be a difficult video, but we're not going to write any code, and I don't expect you to fully understand it. I would say sit back, relax, try to think about some of this stuff high level, and then in the next couple of videos, as we actually start building some of these objects, I hope a lot of it will start to make sense.
And we are back. What is up, everybody? This playlist is probably harder than I thought it was going to be, but also we're covering the things that we need to know in Swift. So although it is hard, I think getting through it the first time is the hardest part. And then once we actually start writing our code and building apps, it's going to be much easier, much more fun. For anyone who's following along, I want to strongly point out that the next playlist after this I have is called the Swift UI Bootcamp. That is a purely UI-based playlist. So everything is literally like building fun screens. And that is much more engaging and interesting than this playlist. This playlist is covering the syntax of Swift so that you can understand the actual technical implications of the code you are writing. So I want to just stress that because I don't want people to fall off at this point thinking that, oh, I'm never going to learn this stuff. We're starting sort of difficult because we want to really learn the actual language. But after you complete this playlist, the next playlist, when you start building the screens, the code is actually way easier than what we are doing in this playlist. Because when we're building screens, we can see in real time how the screen is updating, if the color is red or blue. And that's honestly much more fun than learning this stuff. I think this stuff is just a requirement to kind of get the basics down. So if you're following along, please do not get overwhelmed. We are purposely jumping into this to kind of just get a bunch of this stuff into your toolbox. But I promise you, after you get through this playlist, the next playlist, you're going to feel like is a piece of cake. All right. So what are we going to do in this video? Well, this video will actually be basically zero coding. We're going to do a lot of talking here. So probably the most boring of the videos in this playlist, but there's a lot of really important stuff that we need to talk about before we actually start writing our own data types. So let's right click the navigator, create a new file, new playground page, and let's call this one object-oriented programming. And I'm going to, again, delete this code. We're not really going to write much code here, but I'm going to put a ton of comments for you guys. So let's do a multi-line comment and then just press enter just so there's a lot of space to write stuff. All right. Object-oriented programming, there are probably courses at colleges that will cover what we're going to cover over the course of a whole semester. I'm going to try to narrow it down to beginner level information that you do need to know, and we're going to try to do it in 20 minutes. So a lot of stuff to take in here. A lot of what I'm going to talk about, you don't fully need to understand at this level in your coding career, right? So there's a lot of things that are really complex that when you become an intermediate and advanced level developer, you should come back and really dive into. But at this point, I want to just briefly touch on some of this stuff, just so that when you hear these keywords or you read an article with some of these keywords, you kind of understand what is going on. All right, so we're going to talk about object-oriented programming. And we're going to talk about it specific to Swift. So during the life of your app or any app, we create and destroy objects. So I'm going to say we create and destroy objects. That means we write code that will create the object, and then we don't need it anymore, we will delete or destroy the object. Okay, so when I use the term create, that's not really a technical term. Create really means to initialize an object. And in code, that's going to be the init. And you'll see this word init throughout as you're writing code, as you're watching tutorials. So init means initialize, and that's how we're going to create the object for the first time. And when we create, let's put an equal sign here actually. And when we initialize objects, we are really allocating them into memory. So I'm going to put the word allocate here, and that's adding it to memory. All right, so when you are creating an object, it comes into memory, and we do that through the initializer. The initializer is just the first function that creates the object. Later, we will also destroy objects. And again, that's not a technical term. The function that runs when we destroy an object is a deinitializer. So I'm going to put deinitialize here, and that is the deinit. Explicitly writing a deinit in your code is not very common. I'm going to show it to you in an upcoming video, but most of the time we really just worry about the init, and then we let the deinit happen automatically. But when we do deinit, we are actually deallocating from memory. So removing the object from memory. All right, so you create an object and then you destroy an object. Now, Swift has something called automatic reference counting. And we refer to this as ARC. This is a very popular iOS interview question. Automatic reference counting sounds way more complicated than it is. Really what it is just a live count of the number of objects in memory. And it's as simple as literally counting the objects. So when we create one object, the count goes up by 1. If we create 2 objects, the count goes up by 2. If we destroy one object, the count goes down by 1. All right. So this is not rocket science. If you create 100 objects, your count is up to 100. Now, the reason we're talking about this is because the more objects there are in memory, so the higher the count, the slower the app performs. Okay, so the higher the count, the slower the app. Now, if you are, writing a beginner level app and you have a couple basic screens, you're not doing anything crazy, you don't need to worry about the memory. The iPhone is an incredibly powerful device. It can perform loads and loads of calculations before the memory is going to start to slow down your app. So it's not something that you really need to worry about right now. But generally at a high level, we need to understand that we want to keep this as low as possible. So I'm going to put a comment here that we want to keep the arc count as low as possible. As low as possible, meaning as low as we can do it while obviously still running our app, right? So if we need to add objects to memory to run the app, we will. That's not the trade-off. But if there is a situation where maybe we're creating extra objects that we don't really need in our code right now, then we want to basically fix our code so that we only create objects when we need them. And I'm going to put a comment here. We want to create objects only when we need them. And then the contrary, we want to destroy them as soon as we no longer need them. All right. And I'm going to put a quick example here. So for example, let's say if an app has two screens and the user is moving from screen 1 to screen 2. All right. When we move from screen 1 to screen 2, we only want to create screen 2 when we need it. So that would be when the user maybe clicks a button to segue to screen 2. All right. And then the contrary, when we get to screen 2, we may want to deallocate screen 1. All right, so let's think about this. User has two screens in their app. They're going from screen 1 to screen 2. So when your app first loads, you could load up both screen 1 and screen 2. But really, we don't need to load screen 2 until the user is going to it. So when the app loads, we really want to only load screen 1. And when they click a button at that time, we want to create and allocate memory for screen 2 when we need it. And then if we're on screen 2, right, if we get to screen 2, if we don't need screen 1 anymore, then we may want to deallocate screen 1. And I put this as a may because like if the user is going to go back to screen 1, maybe you want it to still stay in memory. But generally speaking, this is kind of how we want to think about our code. We want to create objects only when we need them. We want to remove objects as soon as we don't need them anymore. Again, I'm going to say this 100 times in this video. If you're following this course, like the next maybe 50 videos, we're not even going to deal with memory, right? That is a intermediate to advanced level topic that you don't really need to spend a ton of time on when you're just learning how to code. But to become an expert developer, you need to have a good grip on what is actually happening. So as you start to actually write your code, you should understand at least that we want to keep the arc count as low as possible. Now, so far I've talked about adding to memory. Well, memory is actually divided into two types of memory. So I'm going to put here, there are two types of memory, at least on an iPhone. And these types are called the stack and the heap. All right, and the most important thing that we want to note is that only objects in the heap are counted towards arc. All right, so when we talk about this object count going up and down, that's only referring to the objects that are in the heap. And that's because there's a technical difference between objects in the stack and in the heap. Before we move forward, I do just want to point out here for anyone who is watching this video that is already familiar with Swift and maybe memory management, I do have an advanced video on this. So I'll put a little advanced info here. And this is another video on my YouTube channel called Struct versus class versus actor, value versus reference types, and stack versus heap. It's in the Swift concurrency playlist. So if you already know what I'm talking about, check out this video. It's an hour and a half long, specific to this subject that we're talking about here, and it dives into the technical details, the technical differences between stack and heap. But if you're just following this playlist and you're just learning how to code, This video is going to be way too advanced that you don't even need to, I wouldn't even watch it yet. Just want to let you guys know that it is there if you want to do a deep dive. But in this video, we're going to try to explain this in the most simple terms that we possibly can for developers. So stack and heap, right? So let's talk about the differences a little bit. So first we're going to talk about objects that are in the stack. And objects in the stack are most of the basic types that we've been using throughout this course. So there are strings, there are booleans, integers, most of your basic types like that we've been using, dates and things like that, those are all in the stack. Things that we have not covered that are in the stack, and I'll put this as new, are structs and enums. And I'm going to cover struct and enum in the next two videos, actually. So this is kind of what we're getting towards. We're going to start creating our own objects. So these objects will be in the stack. On the contrary, we have objects in the heap. And again, most of what we covered has been in the stack, but functions are actually in the heap, as well as what we have not covered are classes and actors. So we're not going to cover actors in this playlist because you really don't need to know that for a very long time. That's in the Swift concurrency playlist I have on my channel. But classes we are going to cover, and it's important to understand that classes are stored differently than structs. There's a lot of confusion between the difference between a struct and class. And there are fundamental differences both in code and how they're stored in memory that have impacts on your app. So again, objects stored in the heap count towards arc. Objects stored in the stack do not. And so when we think about the iPhone and running code on an iPhone, the iPhone is what's called a multi-threaded environment. And when you're running code in an iPhone, you're running it on a thread. You could think of a thread as sort of like an engine. And so a multi-threaded environment really means that there are multiple threads running simultaneously. And I'm going to put threads, I'm going to also call them or engines. So an easy way to think about a thread is like an engine. So if I have a bunch of engines in my app, I can put all of my code onto one engine, or I could divide it across a bunch of engines. And obviously, if it's on a bunch of different threads, it's going to be a little bit more performant because those can act individually. So each of these threads, each thread has its own stack. But the contrary, there is only one heap for all threads. All right. So again, we have stack and heap. These objects are in the stack. These objects are in the heap. Now we have an environment, a multi-threaded environment. So there are a bunch of threads running in my app at the same time. Each of these threads has its own stack, but all of these threads are using the same one heap. And so therefore, we can conclude, therefore, the stack is faster than the heap, and the heap is slower because the heap is being one heap for all threads. So it needs to synchronize across all of those threads. You could imagine a bunch of different threads trying to access the same piece of data in the heap, whereas in a stack, you never have that problem because each of those can act independently, right? They each have their own stack. So stack by default is faster and the heap is then slower. And the memory footprint is on the same lines as well. So a stack has a lower memory footprint, generally speaking, and a heap would have a higher memory footprint. So remember, objects in the heap are counting towards that count. And what this basically means is that the stack is preferable. So if we can create objects that would then fall into the stack, we would prefer it. And this is why if you use Swift UI, you'll notice that when we start creating our screens, every single view in Swift UI, every single screen is a struct. And that's because structs are faster and they have lower memory footprint. And this is why Swift UI apps are highly performant. Of course, if we could use stack all of the time, we would, but we can't. And there are cases where we're going to need functions and classes, and so we will need to use the heap as well. So it's not like we're going to pick one or the other. We need to just understand that there is a difference, and we need both of these to work together in order to build a really good application. All right, now I'm going to take this one final step further. I don't want to overwhelm you guys again, but so we have the stack and we have the heap. We've learned that there's a multi-threaded environment and that every thread has a stack, but all of the threads share one heap. So now logically, we need to figure out, okay, why are these objects in the stack and these objects in the heap? What is technically different about them that these require them to be in a heap and these do not require to be in the heap, right? Like, why could we not put a class in the stack? And there are technical reasons that there's a difference here. And so underlying this all is what's called value versus reference types. All right, so objects in the stack are value types. All right. And when you edit a value type, you are basically creating a copy of it with new data. So if I have like a Boolean, right? Object in the stack is a Boolean. If I have it as true, and then I change its value to false, what I'm actually doing in code is creating a copy of the first version and then altering it and creating a new version with the new value. So I'm going to create a copy and then paste a new value. So think of it literally as like copy and paste, except when you paste, it has a new value. So when you're copying and pasting, there is an old object and now there's a new object. It's not the same object that you have changed. You have copied and then you've pasted a new version of it. The contrary is objects in the heap are reference types. All right. And so when you edit a reference type, you actually edit the object that you are referencing. So here we're going to copy and paste a new version. Here we're actually going into the existing version and then editing it in place. So it's not creating a duplicate copy with new data. Now we're actually just editing the data as it is in place. So what I'm going to put here is this reference. So I said that when you edit a reference type, you are editing the object that you are referencing. So this reference is actually called a pointer. And that's because it points to an object in the heap in memory. So the reference, when we are referencing an object in the heap, we are actually referencing or pointing to that object in the memory of the heap. And so we're going to point at that object and then change that object in place. Whereas here we are copying and pasting a new version. Here we are editing the object in place. And that is basically the fundamental difference between these two types. Because if we think about copying and pasting, right? If we go back to this line up here where we talk about the threads, every thread has a stack. So you could imagine if you had data on one thread and you wanted to move it to the next thread or to the next thread or to the next thread, it would be very easy to just copy and paste a new value on the next thread, right? We don't have to worry about where the object previously was because we can just copy and paste it onto a new thread. So value types can be in the stack because we can just copy and paste them onto all of the different threads. Whereas the heap, when we go to edit it or move it, we're always pointing to the same location in memory, right? So that's why there's only one heap, because whether or not it's on the first thread or the second thread or the third thread, when we move it from thread to thread, we're not actually creating another copy. We're instead just sharing the pointer to the same object in memory. So even if there are multiple threads using this data, all of those threads are pointing to the same pointer in memory. And that's kind of the fundamental difference here. So again, stacks are faster, heap is slower, but there are use cases for both of these, and we just want to understand high level what the differences are. Because stacks are basically value types, and we can basically copy and paste them, there is no risk for threading issues. Whereas because the heap is shared across all threads, we have risk for threading issues. So I'm going to put here risk of threading issues. And I'm not going to really talk about threading issues, but you could imagine that there are multiple threads accessing the same piece of data at the same time. That could cause a problem. So again, this is kind of just high level here. I really do wish there was an easier way to explain this all. Before we wrap up this video though, I want to just show you guys, let's create our first. So we have here objects in stack. Struct is an object that is in a stack. Class is an object that is in a heap. We're going to create a struct and a class right now. So I'm going to come down here. Let's create our first struct. I'm going to call it my first object. And I will open the brackets. This is a new data type that is a struct, and I'm calling it my first object. I'm also going to create a class. I'm going to call this one my second object. And I will open the brackets. And you're going to notice that these look exactly the same. We can even put a title in each of these of maybe of type string that says hello world. And I can put that in both of these. And so this is part of the reason why structs and classes are very difficult to grasp, because they look the exact same in code, right? Like I can make this a class, I could make this a struct. Both of these will compile and nothing will tell us whether or not this is right or wrong. So at face value, when you're writing this code, nothing is telling you what these differences are. But now you guys should know that structs are going to be value types and classes are going to be reference types. And in the next like 3 to 5 videos, we're going to do a deep dive on what actually is a struct and what actually is a class. Because when we actually start using them, because they are different types, we're actually going to have to use them differently in our code. And I'm going to get more into that in like the next couple of videos. Before we wrap up, I want to give you guys one quick metaphor that I think will help somebody. So what we're going to do is explain class versus struct explained to a 5-year-old. All right. So I don't want to offend anybody here, but I'm going to try to make this as simple as possible. And anytime you do a metaphor like this, obviously there are places where it breaks down and it is not perfect, but I think it is worth to at least try to explain this, because I remember when I was learning how to code, it took me like, I don't know, a year and a half just to really grasp the differences. And I wish someone had given me this metaphor earlier in my coding career, because there's so much time when you're learning to code that you're just making it a class, making it a struct, and you don't really know which one is which or which one is correct. So I'm going to try to break that down with a really simple metaphor here. And let's imagine a school, and in the school, there are classrooms. All right. Within each classroom, the teacher is going to hand out quizzes. So there are quizzes. And during the day, the teacher will hand out many different quizzes to different classes. So maybe there's like 5 different classes throughout the day. Each class has a different quiz. And the students will answer the quizzes and return them back to the teacher. So trying to keep this super simple here. So in this metaphor, imagine a school, and the school has classrooms. All right. And so in this metaphor, the school is our app. The classroom is a class, and the quiz is a struct. So just like there is a school, and inside the school, there's a whole bunch of different things happening. We're going to create an app, and inside the app, there's a whole bunch of different things happening. Now, a class is just like a classroom. So we're going to create a class, and then we're going to do things inside that classroom. All right. Again, this is the heap, right? So every time we are changing it, we're editing it, we're editing it in place. So the classroom is not moving, right? The classroom is in place, and we're going to go and do actions inside the classroom. One of those actions might be users taking a quiz. And so the quiz is then going to be a struct. So every time we go to hand out quizzes, we're going to make 50 copies of the quizzes and hand them out to all of the students. That is the value type. These are smaller pieces of data that we can easily pass around our app. So the classroom is really not moving. We're going to create the classroom once, and then we're going to do a bunch of things inside. The quiz, however, is moving and changing and getting edited all the time. So these structs we can whip up, we can move them around, we can pass them around our app really easily. Whereas the classroom, it's much harder to do that. All right, so just to write that down real quick, in this example, we have a classroom, and there are many actions that occur inside the classroom. And in code, we create a class and can perform actions within class. In this example, there are many different types of quizzes. So there are many different quizzes. There are different types of quizzes. Every quiz by each student looks a little different. There's a different name on each quiz. And the teacher hands out the quizzes, and the students take the quizzes and return them to the teacher. So in code, we create many structs and pass them around our app with ease. It's much easier to pass around a quiz than a classroom. Much easier to pass around a struct than a class. Now I'm going to put a quick note here that this metaphor is not perfect. Technically, a quiz can be a class. I'll put etc. here. So technically, we can create quiz, right? We can create a quiz as a struct. We can create a quiz as a class. Each quiz would have a title. And no one's going to tell you the right or wrong way on how it has to be. But generally speaking, I think when you're creating your app, think of a struct in the same way that you think of like other things that are value types. So we come back up here, we have like strings, booleans, integers, structs. So the same way you think of like a small piece of data, a boolean, a string, we think of a quiz, right? It's just a small piece of data that we're going to create. We're going to maybe edit it. We're going to pass it around our app. Maybe we're going to use it in a bunch of different classrooms. Whereas the classes are, we can still edit them, of course, but we want to use classes for things that are a little more stable in our app, not so much that we're going to pass around our app. So wrapping up here, we want to use a class for things like, and if you're following this playlist, you don't know what any of these are yet, but if you see a tutorial that has something like a manager or a data service or just a service or maybe a factory or maybe a view model, if you learn MVVM, these will all be things that are classes. These are objects. These are objects that we create and want to perform actions inside. On the contrary, we want to use a struct for things like, and I'm just going to put here data models. So the same way you think about a string, a boolean, a piece of data that we want to share around our app, these are objects that we create and pass around our app. And again, we can pass around either of these objects types. We technically can pass around our app. But as we already learned, because each thread has its own stack, it's much easier to move value types around your app because we can copy and paste the new data rather than having to edit the data in place. All right. I think that is all I have for this video. That was an incredible amount of me talking, and I'm sure there are a lot of people that are really confused now. What I will say is that the next couple videos, we're going to do an entire video just on structs. We're going to do an entire video on something called enums, which are everything I put up here are also part of the stack. And then we're going to do an entire video on classes. So after the next couple of videos, this should all get much more clear to you guys. I just thought that it was important to get all of this out in the open so that you can start thinking about it. I do not expect at this point in your coding career you to understand any of this at a deep level. I just want you guys to understand that there are differences. And as we write our code, we need to think about if the objects we are creating are going to be structs or classes. And because there are going to be implications based on which one that we choose. All right. Leave a comment below if you are incredibly confused, or leave a comment below if this helped you out. This is really, really intense. This is really complicated stuff. I do not expect someone to just watch this the first time and fully understand it. But at a very high level, understand that in iOS, we are using object-oriented programming when we're going to create and destroy objects over the life of our app. Swift uses something called automatic reference counting, which is counting the objects in memory. Every time we create an object, the count goes up. And we want to generally try to keep our memory footprint as low as possible because that will be a more performant application. The memory is then divided into two sections. There is the stack, and then there is the heap. And objects in the stack are things like strings, booleans, integers, structs, basically any sort of data type that you're going to then pass around your app. Objects in the heap are things that are like classes and functions, things that are a little more stable where we are going to create code and then we're going to do things inside of that code. At a high level, an iPhone is a multi-threaded environment, meaning there are multiple threads running at the same time. And we can make use of these threads to make our app more performant. But what we need to know is that only the objects that are in the stack can act independently on these different threads. Objects that are in the heap, such as classes, are going to be shared across all of the threads. And because those objects are shared, they're then a little bit slower. So generally speaking, if we have an option, we want to use objects in the stack because they're faster, they're going to have less memory footprint. But there are going to be cases where we need to use objects in the heap. And so even though those are a little bit slower, a little bit higher memory footprint, a little higher risk of other issues, we do still need them, absolutely need them in our code for certain use cases. The main difference between what's going to go into a stack and a heap is whether or not it is a value or a reference type. Value types, when we edit them, we basically create a copy and then paste a new version of that with the new data. When we look at a reference type, we don't copy and paste. We instead point to the object in memory and then change it or edit it in place. So we are not creating a new version with new data. We are just pointing to the existing one and then editing it in place. And so that's mainly the difference between a struct and a class. A struct is a value type. So when we edit a struct, we're going to copy and paste. A class is a reference type. So when we edit a class, we are editing the exact object that is already in memory. I'm not going to go through this metaphor again. High level, we want to use classes for things like managers, view models, data services, objects that we're going to create and then perform actions inside of the object. We want to use structs for things that we want to then pass around our app. So things like data models, similar to a string or a boolean where you want to pass it around, we would create a struct and then pass that around nice and efficiently. All right, very, very difficult video here, but the next couple of videos should clear it up because we're going to dive into structs, enums, classes, and all of that good stuff. Thank you guys for watching. Again, please do not worry if this is not fully making sense to you. This is really intense stuff that you don't fully need to grasp and understand at this level in your coding career. If you're just getting started in Swift, I wanted to just introduce you to this so that we start to think about it. And then later when we actually need to learn it, you'll come back to this and actually understand it. But for right now, just take it at a high level, understand that there are differences. And the next couple of videos, I'm going to show you how we can work with structs and classes and kind of highlight some of their differences. Thank you guys for watching. As always, I am Nick. This is Swiftful Thinking, and I'll see you in the next video.